Hello everyone, welcome to the operation guide of the IT7900P series. We'll start up here in the front panel. Let's go to the left. Here you'll have the power and on knob. It's a simple switch between off and on. Then we'll have our USB port to import, export any USB files, firmware updates, CSV files. Then we have these three buttons. Print is to take a screenshot, trig is to do a trigger on the unit, and menu to go over all the other optional features this instrument offers. Over here we have a 5-inch touchscreen display. Lets you edit all the voltage values, displays the real value on the output and for voltage and current, and also other different values like power, crest factor, power factor, and total harmonic distortion. Moving up to the buttons here, we got our set to set the voltage, offset to set the frequency, config to enter the configuration menu, which I'll talk about later. Here, these three buttons change the view of the front panel. Here, we're in the meter mode. We can go to the oscilloscope mode and also to the harmonic measurement mode. Down here, we got the on-off button, shift to access the alternate menu that you can see on the blue letters, and escape to escape any specific menu we're in. Let's go back to the meter mode. We also have a numpad over here where you can set up all the voltage values with, and arrow keys for navigation, as well as a control knob. Now we're going to be going over some of the basic menus this instrument has. First, let's jump into the system menu we can see on the blue letters. Here we're going to be able to set up our power supply either as a voltage source, load, or as a current source. We also have the phase mode option to switch between 3-phase, single-phase, reverse phase, or multi-channel. We can set up our couple mode between AC or DC mode, and the programmable output impedance this instrument offers. There's some other settings like external frequency lock, or the loop speed between medium, high, or low. Moving on to the general settings, we can set up the buzzing sound that the units make, set up the screen brightness, or reset to factory default settings. There's some other settings like when setting up a parallel unit, we can set up as a master or as a slave, and also if we want the knob to be effective or not. Moving on to the communication, here we can set up remote communication with our instrument. It can be either USB, LAN, CAN, or optional GPIB. In the I/O section, we can set up the functionality of the digital I/O pins on the back of the panel. We have all the way up to 7 different pins we can set up. Here we can set up either like pin 5 to do an interlock function that'll only work once you give it a high or low signal to this specific pin. Moving on to the information part, we have the product model, serial number, and firmware version of the instrument, along with other factory settings. Going into this next menu, we're going to the configuration menu. Here we can do the setting directly of the voltage. We can do balance control if we want balance between all 3 phases. And we can also do specific waveforms on each phase. Right now I have it set up as sine in each phase independently. Last but not least, we got the protection menu. This is pretty useful. We can set up limits or protection limits that our instrument's gonna work within. Here we got the current RMS protection. Anytime the current RMS goes over this specific limit, the instrument will start beeping and the output will be disabled. We have for current and for voltage as well, and a power limit range as shown. Now we'll start doing a basic operation of this power supply. First, let's set the voltage at what we want to work on. First, click the set button and input the desired voltage. This example, we're going to do 120 volts RMS. Input 120 and then click enter. As you can see, the values have been set on the front screen. Then we can move on to frequency set. Just click the F-set button and then input 60 and then click enter. As you can see, the value has been entered. Once you have all of this set up, your voltage, your frequency, and I would always recommend setting up protection values with the protection menu, you can start outputting. In this example, we're going to start outputting 120 volts at 60 hertz frequency. As you can see, the instrument right now, it's displaying 120 volts across 3 phases. Since we're not connected to any load right now, there's no current flow. But we can see also the frequency up top. To turn off, just hit the on-off button again, and you're all good to go. Your output is now disabled with 0 volts across all phases. Now let's take a look at the rear panel of the IT7900P. First, here on the left, we have the output terminals with line 1, 2, and 3, and neutral. We also have our earth terminal and voltage sense terminals for voltage drop-off configurations. We also have our option slot for GPIB or analog, and digital I/O pins for specific functions on each pin. Our CAN high and low pins are used for CAN communication, and the RJ45 port for Ethernet. We also have control pins to power on multiple units in parallel configurations, and the USB port for USB communication. For system bus, when having multiple units, we use optical fiber, which are these 2 ports, and this is used for better speeds and down to the microseconds. Here on the right side of the unit, we have the input connections. It's your 3-phase power going in, and that's about it on the rear panel of the IT7900P. The IT7900P's comprehensive feature set, from harmonic analysis to regenerative load capabilities, make it an ideal choice for testing in renewable energy, grid simulation, and power electronics. For further guidance, refer to manual or contact our support team for assistance.